this. Of course, the normal equation, which is f of x is equal to 1 all over square root of 2 pi sigma squared exponential negative 1 all over 2 sigma squared into, here we have, say, y minus xb squared. So this is what we get. Using the regression normal equation, this is what we get. It means that our error term, we should understand that our error term follows a normal distribution of 0 and sigma squared. You have the identity, and y follows a normal distribution of xb and sigma squared, and we have our identity. So this is what we have. Of course, this is the normal regression equation. Now, we have two parameters here. We'll be looking for the mean, which is beta, and we'll also be looking for sigma squared. In fact, that is what we are looking for. So here we are asked first to find the likelihood function and also derive the maximum likelihood of this. So the normal equation this question is referring to is what we have here. Now, the first thing to do, we have to write this well. Of course, in our previous lesson, we have discussed how the whole of this came about this. That means, for more on this topic, you need to subscribe to this channel. Now, what we need to do is to show how the whole of this regression normal became this. We have here that the sum of square error is given as this. The sum of square error is equal to summation of e square, which is our error term. And if we make this e the subject of formula, we'll have something like, if we make e here the subject of the formula, we'll have y minus xb naught square, which is the same thing as y minus xb So that is how it came about. So what we have here, we now impute it into this. So we'll be having our normal equation to be f of x. Since we are looking for beta and sigma squared, we'll have it to be 1 all over square root of 2 pi sigma squared exponential negative 1 all over 2 sigma squared into, now we have y minus xb and y minus xb. So this is what we have. Now we'll move over to what we have here as the first question. We have to obtain the likelihood function. And what is the likelihood function? The likelihood function, which is denoted as this, of any function x b sigma squared, is the product sum as I running from 1 to n of that function. Is the product of that function. Is the product sum of that function. So we'll have this. So we'll take the product of this. We can easily write our likelihood function to be x beta squared to be equal to the product sum as I running from 1 to n. Now we put this 1 all over square root of 2 pi sigma squared exponential negative 1 all over 2 sigma squared into y minus xb prime, then y minus xb, which is gotten from the regression equation. So that is what we get. Now, to find the likelihood function, we just take the product sum of this. The product sum of this is also equal to, we first have 1 all over square root of 2 pi sigma squared, the first one. Okay, we use this exponential negative 1 all over 2 sigma squared y minus xb and y minus xb multiply by, we come again, we write the second one, 1 all over square root of 2 sigma squared exponential 1 all over 2 sigma squared y minus x beta and y minus x beta. So this is what we have as the second one. The multiplication still continues, so we have multiplied by, it continues to still give us, this is the second one, 1 all over square root of 2 sigma squared raised to the power of n exponential negative 1 all over 2 sigma squared y minus x beta and y minus x beta. So this is what we have. Now we can now write our likelihood function, but for we to do that, we move over to this side of the board to write our likelihood function before we now find the maximum likelihood. So we have to delete this part of the board to do that. It is quite easy. We are just looking for the likelihood function here. So for more on this topic, you need to subscribe to this channel. Now, how do we write our likelihood function? We said the likelihood function is the product sum of the given distribution. Now, this is the regression normal distribution. We are taking the product sum. We have multiplied it, and it continues like this to the end. So we'll move over to this side of the board. For more on this topic, you need to subscribe to this channel. Now, we can easily write our likelihood function. Our likelihood function can be written as this. F of x beta sigma squared to be equal to 1 all over square root of, we use the last one, 2 sigma squared raised to the power of n, because it goes n times. If you sum anything, if you are putting it together, if you take the product sum of anything, if you are putting it together, it will become n times that thing. So we have here to be exponential negative 1 all over 2 sigma squared into y minus xb and y minus xb. So this becomes our likelihood function. This becomes our likelihood function. We are also asked to find the maximum likelihood. How do we find the maximum likelihood? To find the maximum likelihood of any distribution, we first find the likelihood function, take the logarithm of that function, we differentiate and equate to 0. Now, the next thing to do is to take the log of this function. But for me to take the log of this function, we have to rearrange this properly. Rearrange this properly, which is equal to, if this moves over here, we'll have 2 pi sigma squared into, this is 1 negative 1 all over 2 multiplied by n, which is exponential negative 1 all over 2 sigma squared y minus x beta and y minus x beta. So it's also equal to 2 pi sigma squared negative n all over 2 exponential negative 1 all over 2 sigma squared y minus xb and y minus x beta. So this is what we have. It then means that we can split this properly so that when taking the log, it will be very easy for us. Now we can write this as 2 pi, we split it with the negative n all over 2 from indices multiplied by sigma squared negative n all over 2 multiplied by exponential negative 1 all over 2 sigma squared y minus x beta and y minus x beta. Yes, which is now our likelihood, which is still our likelihood function. Now, the next thing to do is to take the log, the logarithm of this function. Is to take the log. So we just write here, taking the logarithm. If we take the logarithm, we have log of our likelihood function, log of our likelihood function. If we take the log of this, we have negative n all over 2 ln 2 pi plus this negative n all over 2. If we take the log of this, ln sigma squared, and we take the log, if you take the log of an exponential function, you get that function, just that function. So we have negative 1 all over 2 sigma squared y minus x beta and y minus x beta. So let this be our equation star, because we will recall it. Let this be our equation what? Star, because we will recall it. Now, as we are taking the logarithm function, the next thing to do is to differentiate with respect to the parameters we have here. Here we have beta and here we have sigma squared. So this becomes the mean and this becomes the variance. This is what we are looking for. For me to do that, we move over to this side of the board to do that. So for more on this topic, we need to subscribe to this channel. We have to delete this part. For more on this topic, we need to subscribe to this channel. For more on this topic, you need to subscribe to this channel. So, we will not differentiate with respect to beta. We differentiate with respect to beta. How do we go about this? So, we say to minimize or maximize the function, you differentiate and equate to 0. So, to maximize beta, to maximize, to maximize beta, we differentiate with respect to beta. So to maximize beta, to get obtain beta, we differentiate with respect to beta. Now to differentiate with respect to this, we have something like this. The differential of log likelihood function x beta sigma squared all over the beta, which is equal to, now we are differentiating with respect to beta. If we differentiate with respect to beta, if you check the whole of this, there is nothing like beta here. So it automatically becomes 0. So we write here 0. Also, we move over here. If we differentiate with respect to beta, we will have 0 because there is nothing like beta here. So we also write minus 0. And now we differentiate this with respect to beta. If you differentiate this with respect to beta, you get plus 1 all over 2 sigma squared into, you get the regression normal equation y minus xb. So this is what we get. The next thing to do is to equate what we have here to 0. We equate this to 0, what we have here. So we have 1 all over 2 sigma squared into y minus xb and y minus xb to be equal to 0. Now, of course, this can multiply this to remain y minus xb, y minus xb, which is equal to 0. Now, it then means that we will now write the meaning of this. The meaning of that in regression, it then means that our b estimate will become x transpose x into x transpose x minus 1 into x transpose y. That is simply the meaning of what we have just written here. So it then means that our beta estimate is equal to x transpose x. X transpose x inverse of x transpose y. So this becomes what we have here. So this becomes our beta estimate. We have succeeded in maximizing the beta estimate. The next thing to do is to also maximize that of the sigma squared. We maximize that of the sigma squared. We are asked to find the maximum likelihood estimation for the regression normal equation, and that is what we are doing here. So we have to delete this part of the board to also obtain the sigma squared. That is